This is Pat, and here's the Wagner spray gun. So we can kind of spin it around and take a look at some of this stuff. The gun was designed to solve a lot of problems. Some of the problems are as simple as just cleaning up at the end of the day. And when you're spraying inside of a tight quarters, overspray kind of flies around all over the gun. And so there's an overspray shield that goes over this. I'm working on that today. So just remember, one of the last figures in the patent is going to be an overspray shield that snaps over this. It's very similar to packaging. I had it on another design, but this design has me starting over again on that one. And we'll include that in the documents that are coming over. So here on the right, this is polymers coming in. They screw in to these stainless steel fittings in the back, and it's high pressure fittings. So these are actually swivels here, and this swivels and this goes into this aluminum body here. So these are mirror images, and we've got wrenches on the fitting here, so when you tighten it, you can tighten it up, and we'll probably put Loctite in this in production so this doesn't back out. And then these swivels, so you can disconnect your hoses here. So that's the incoming material. So this gun is designed to work with what we refer to as off-ratio blends and polymers. So they're plural components, so one side comes in this side, the other side comes in here. Usually one is labeled A, which is the resin, and B is the hardener, generally an isocyanate. So we're going to work with epoxies, ceramics, urethanes, polyureas, polyaspartics, structural foam, insulative foam, and they'll all process through this gun. And one of the problems that happens in a gun is that they jam up. And guns have been traditionally designed with tight tolerances, and this particular gun, it's got loose tolerances, and we'll show you why. So there's working parts that are inside of here. The air comes in through the back to push a pin through, and the pin pops out here on the end. Everything's radial design. A lot of the guns don't have any radiuses, and this is used to eject stringers that kind of, they're like stalactites that hook onto things. And so this tip here is a ceramic piece. One of the problems is they've selected materials in the past that are like stainless steel or aluminum, and the material tends to heat up. It's operating at 180 degrees Fahrenheit, and so these materials tend to bind up, and then everything stalls out when valves are supposed to work. So let's take a look at the inside. While we're out here, this is the solvent right here, and there's a rubber piece here and a rubber piece there. We've got these little molded in valves that are called duckbill valves. This feature right here is a over-molded stainless steel puncture device that allows air to pass in here. So we're going to pressurize this vessel, and then we're going to squirt solvent in here when we cycle and let go of the trigger. The trigger is down here, and that's what's in this handle. A lot of these guns have all been made out of steel and aluminum. We have decided to design this out of plastic, the bulk of it out of plastic, to lighten things up. So this handle is this trigger is made out of a glass-filled nylon. The handle's made out of glass-filled nylon. This little crash guard to prevent the handle from bashing or from getting knocked when you drop the gun and let go of it, that's going to be nylon also. These twist caps have a hand tightening feature and then a big wrench feature. These are going to be glass-filled nylon. These are going to be glass-filled nylon. This gun body right here, I'll open this up. This is going to be one of the few aluminum parts, and so this will be a sand-casted part, and these will all be machined out. And here's one of the chambers coming down through, and you can see that the shape of it lends itself to low pressure drops. So as the resins come in, they don't have to turn sharp right angles to mix, and we're all kind of flowing in an outward Y pattern where things, we won't have back pressure and everything wants to go out the tip. So this Y shape is pretty critical in an effective design. So we've prototyped this in the past, and these are some of the air intakes here that are coming in, so we can activate this cylinder that's in the center. But let's close this part and move into the inner workings of the gun. So what happens is, if we take a look at the let's see, the top view, nope, not that view, top view right there, and we'll cut a section through this, and we can spin it around. We've got some working pieces in here. Let me just zoom in and get this so we can look at it. And you've got your A side and your B side coming in. You've got to have a check valve along the way. You'll see this shortly here. So as the resins come in, there's a valve that shuts on and off right here, and then it makes a gradual turn here. This is a keying feature, so your valves don't spin when you drop the gun. This is a hex feature that'll just slip right in there. So that little hex part there, and then we've got this seal right here, so no fluids will leak out at this ring. This ring brings the assembly together. So when we take this assembly off, we can shut off the valve, and then we can take this over to a drum that has the resins in it, and we can cycle it and get it hot. So as the materials race through the hose, they're getting heated, and we can get that drum temperature up quickly. So this has got an adapter that hooks onto a drum, but then it hooks back onto the gun here. So these are typical here. This one's shown without the hex feature in there. And then as the resins come down, you can see that it's going through, and there's this screen that's trapped right here, and this screen can get replaced very easily. All this stuff was designed to be able to push out and clean. Most guns take hours to clean and get all these working parts that are a little bit different than this back clean and working order. The yellow down here, this is a seal that is used to wrap around the main pin here. Let me open this up just so you can kind of see this. So our resins come in, and this is going to be a flexible molded material that will mold over a steel pin that's in there. It'll be keyed on this flat here, so it can't turn, and it lines up with this, with the striking pin that goes through here. This hole right here is a orifice to let solvents come in and clean out the chamber. So you'll see there's some solvent paths that we take. So when the air cylinder pushes this cylinder forward, this ceramic tip is mounted on the end here. It's wrapping around these yellow seals. The yellow pin here in the middle is a striker pin that gets delayed. So what happens is, when they let go of the trigger, an air cylinder pushes this purple part forward that's attached to the cylinder here, and it comes forward, and so now we're sealing off, and the solvents, or the chemistry can't go anywhere. It's stopped right here, wrapped around this pin, and you have a big seal. Most guns that are out on the market have very small seals. This is a stainless steel pin here that's used to handle some of the high pressure loads. Our loads coming in are going to be in the realm of 2,000 to 5,000 psi. And so you can see this spring that's trapped this ball here. The ball is a check valve. It's on both sides. So back pressure can't push resins where they'll mix back together. So that's why we have a check valve in there. And anyhow, so this view is shown where the chambers are forward. Before the striker pin comes forward, we're going to inject the solvent into these little orifices. These orifices are very small. They're like 30 thousandths of an inch, 30 micron. And so the solvent will come through here, and it'll flush out all the A and the B sides. So we clear this out every time we let go of the trigger. This blue part is actually another synthetic rubber part, and it wraps around that striker pin. So we're not going to let any chemicals go back into the chamber that's working back there. So this is a rubber piece right here. And anyhow, so then once the solvent goes through, there's a delay in timing, and this yellow pin strikes forward, and it knocks out any slugs that are in there. So then if you point the gun down, the solvents come down into here and go out. If you point the gun up, then air races through here. So it's kind of a three-purge system, and that's the essence of cleaning the chambers. The chambers tend to plug up in here, and we get chemicals binding up. They cure at like 3 to 5 seconds, and so this tends to fail right in here. and then these working features right here tend to fail. The solvent is a ethylene glycol, which is radiator fluid, and it is used to lubricate and to clean. We've proven that the solvent is a great cleaning system for all of these polymers. It's one of the few things that lubricates and delaminates everything, gets everything off the surface. So we will be injecting that solvent in. There may be a little bit of oil in there to lubricate, but when the whole pin assembly pulls backwards and our air cylinder pushes all of this back, so we've got an air port that comes in right here, and it's going to push this back, we will be able to then go in and start mixing the chemicals. So when they pull the trigger, that's when all this goes back. And anyhow, that's kind of the essence of it. So when you pull the trigger, this will go back, it'll line up, and then the chemistry starts flying in here, and it mixes right at this tip here. So again, radial design to release these stringers. They're what do they call it? They call it bearding. Bearding is a technical term for these plural components when they start creating like stalactites at the tip here. So this shape here will tend to release it. Now all the air that's coming through here will help blow the stringers off. So this is kind of what it is. There's an O-ring seal right here that traps all of this, so the solvents stay in here. This taper here is what holds it all together. So as the chemistry comes in, let's take a look at the next section view, which is the right view here. Let's take a look at this, and we'll section that. Let's see here, right. Okay. So now what we've got here is a view that pretty much shows how the solvent comes into the system. And I've got some solvent views in the patent drawings. And we've got airlines and everything over here, but let's take a look at what this looks like right here from a side view. Let's see if I can get you a side view. There we go. Now, if we come in here, you can see this mechanical striker. This is going to be loose tolerance in here. The ceramic piece is loose toleranced, and so these tend to bind up in here when the chemicals start residing in here, and so we think that we can get more force in moving forward and reverse, because it's going to move backwards and forward. So you can see how the chemicals mix right here at the end, and this striker pin will come flying through and knock out any slugs out of there. And this is our solvent path. So this is the duckbill seals that I was mentioning. Right here is a metal, the air comes up, it goes in, and we puncture the seal here, and we'll be able to introduce pressurized air in here. When you point the gun down, the air pushes the solvent in. The solvent is butted up against here. This knob right here turns that in and compresses all this. And as the air comes in, or the solvent, it's pushing down this tube. It goes around this circle here, and then it comes out on the side. You can't see it here, but that other path, and it blows out all of the chemistry, the A and the B side on the chemistry. So these are, I don't think I have an O-ring shown right here, but actually, excuse me, the O-ring's right here. This is the fluid path for that. So here's the air coming in that the four-way valve pushes air out, and then it exhausts it out this side. So this goes back and forth. It only travels about 3/8 of an inch, and then this pin right here will strike forward. Once this goes forward, the solvents get pushed through. This thing has a delay, and it strikes it forward. So you'll see the delay in the schematics. Here's the handle. Here's the four-way valve down here, and that's essentially it. So we have incoming air that actually comes in on this side here, and it goes down to the four-way valve and provides pressurized air from a air compressor. And so your hose has incoming air, a positive air pressure of about 140 psi, and then we route it all around from inside the handle. And anyhow, that's the essence of the gun. Again, we've got an overspray shield, so there's two consumables. We've got this this consumable here, and then we've got an overspray shield that you don't see here, and that'll be included. Let's take a look at the valve assemblies. I think that the valves have some unique stuff going on here. Let's see here, shut-off valve. So let me open this up here. This is the shut-off valve. I guess I am showing the spin dial off. Here, we'll turn it on, and then here's a label cap that goes on there. So this label cap goes on, and it's got arrows that point in the direction that the material is flowing. So when you're on, the arrow's that way. When you turn it 90 degrees, it's got to stop, and it stops. So a lot of systems, they get partially turned, and you get a off ratio blend where the valve isn't quite open and you're not mixing properly, and the valve is partially open. So we've got some detents that snap this open and close. Let's hide this. Actually, let's take a look at this ring here up front. So this is a sealing surface. Here's the hex that keys it so the valve doesn't unlock itself and spin. So our little hex will fit in there. And then there's an O-ring that seals up against this surface right here that you'll see along the way. And anyhow, this is our valve assembly. Everything's got big wrenches and hand knobs, so you can turn it and tighten it up. And it can't back out. So that's kind of the premise. There is a right and a left to this, and I guess we can kind of hide this this valve body, and you'll see that the seal right here comes in here, and the fluids flow through here. And this is a seal at the bottom, a seal at the top, and that's kind of how it works. So here, I'll turn this on and see if we can get a section view of this guy here, and you can kind of see the working guts of how the material comes through here. A little confusing down here with the hex and how that comes together, just because the way we took the section view straight through the assembly. But anyhow, this is kind of the valve. This cap here that's important for pointing the valve in the right direction, so it's a visual. It's got a little release here where you can stick a pin in there and pop the cap off, so you can get that out, and then you can work on this valve here. There's this dowel pin here keys everything, and that's how that works. So I'm going to get rid of this, and we'll just go back to the assembly, and let's see here. See if I can get us an exploded view. We'll take this and we'll run it through the explosion that's pre-made here, and let's see here, explode. So here's kind of all the essential components coming together. This is that wraparound seal that I was talking about earlier, right in here. So this is kind of the key to the product right here. If I hide this, you'll see this is where the chemistry comes in. Now we're going to size these in two different sizes, because off ratio means that you've got a 1-to-1 ratio, or a 2-to-1, or a 4-to-1, or a 5-to-1. So these, this chamber on this side and this on the other side will be porting how much fluid flows through here. So you can kind of see it highlighted there. And the key to this whole thing is this wraparound. A lot of people just use O-rings that they butt up against a flat surface, and it doesn't seal off, and it's a working surface. And this big, large surface here, I've proven that it holds higher pressures on this. So this is one of the key components. I'm not sure why I can't turn that yellow one back on. It's buried in here somewhere. But that's those guys. These parts here are aluminum parts, and they screw down, and they bottom out, and they set the pressure that this has against this round working surface on the ceramic part. So when we bottom out this this feature right here in the body, right here, this surface from here to the wraparound tangency establishes the pressure on here. So we can set that up, and people won't crank up the pressure too hard. So there's some dimensions that will hold tight there. But this is kind of the keying here. So we don't want this pin to spin, because we want these holes to all line up with everybody. So back here, you'll see that this bushing right here has some flats on it, and we're going to these flats all key everything, and so the flats will prevent this purple part from spinning. Everything's keyed all the way up through the front here, so these all have to line up when they go forwards and reverse. This cap back here, I guess I can hide this. It's just a plastic cap that is going to allow air pressure to push this pin forward and reverse. So this is the striker pin that goes all the way through there. So that's a little bit of a tour there of the design, and hopefully that helps explain what's going on. We can see some of these things down in here, and here's kind of where the solvent flows in here and it wraps around, and that's that part. So the solvent's pretty important. Mechanical striker, nobody has a 3 cleaning solution, so there's kind of a bunch of backup ways to ensure that the chambers are clean. And here's the gun body. It's got a little pivot hinge here that pivots and holds this handle in here. We've got incoming air on the right, and on the left we have exhaust coming out to do that striker pin, and then everything else is kind of running on the inside. Let's just hide this handle here for a second, and you can see there's a T here that sends air up to here, and at the same time it's going up to the back side that's going to provide air to the striker. So there'll be a delay going up here and an accumulator in here. You'll see that in the schematics. And then we've got this handle. So everything is kind of laid out to, let's just go back to the unexploded view here. And everything's kind of laid out to be easy to clean, push out these valves, swap out mixing chambers because you're mixing a different chemistry one day, and cleaning up. I think that the cleanup on everything is pretty important. Let me get this handle back, and anyhow, so that's what we've got. Oh, we do have a case that all this stuff comes in, so you'll get 10 of these solvent cartridges. You'll be swapping them out a couple times a day, and depending on how many times you pull the trigger, we're going to measure increments of solvents that'll go through there. We're not going to use it all up in one shot, so we want to make sure that every time you let go of the trigger, it just cycles through and gets that going in there. So this is basically what we've got. Let's see here. That's it. So anyhow, hopefully that was helpful, and we look forward to working with you on this. This is Pat Conroe signing off. Where's my off button here?